What's up, guys? Zach Scriven. I'm back again. I just had to do a little bit of tweaking. So what I just went live. I'm gonna do some work, some 9 to 5 stuff. I'm working from home today, and I'm gonna live stream my work. And it's not actually gonna make me do less work. It's actually gonna make me do more because I'm very focused on providing as much value, getting as much work done in as short as possible. I'm gonna probably stream for about 3 hours. At 5 or 4:30 or so, I do have to go to take care of a few personal things, but basically what I'm doing today is I'm live streaming development of a PLC project. And so I had to stop though because my desktop wasn't working with VMware. So like, this is my desktop right here, and this is the one I'm streaming on. The VMware, it's Windows 7. There was some compatibility issue, so I think my CPU is too old on my desktop, so it wasn't compatible. So what I did was I set up my capture card and I plugged in my laptop. So this right here is my work laptop, and I have that outputting via HDMI to my PC, which is then streaming. Let's see, I don't know why the capture card, I'm gonna mute the capture card for now. So then in the desktop audio should still come through. So if we play some music, how's that sound, guys? All right, let's get into it. So this is be desktop 1. I'm gonna probably put my my drawings here. I got some drawings here. Submittals, control panel, Rev 2. So these are what I'm going to be developing the code off of. This is the control panel drawings that we're building. So there's all the submittal parts, but really what I'm interested in is the drawings here. And let me know if my audio levels are kind of out of whack or something. So yeah, this is our control panel here. All right, there we go. Yeah, this looks more accurate. Okay. The one I was looking at before was a previous revision. The panel grew in size. So there we go. Alright. This is the AC distribution, DC. But here's the DC. What I'm interested in is this right here. So these are the tags that we've got going for this system right here. See, we got pump 1 in remote, pump 1 running, pump 1 fail, pump 1 motor high temp, and then pump 1 motor high moisture. So then we got that same pattern for pump 2 and pump 3. Then we have a float switch, a level switch high, a level switch lag. So that's going to start the lag pump. Level switch lead, that's going to start the lead pump. So we're going to need a way to indirect lead and lag. We'll probably use like a boolean for that. Then we have a low level switch low, and a level switch low low. And over here we have some more pump 1 running command. So these are our outputs: pump 2 running, pump 3 run command. Then it looks like high hydrocarbon level, we have a output. That's interesting. So maybe if there's a high hydrocarbon level, we trigger that output. High oil and water detection, high basin level. So if we get that level LIT1, looks like if there's a high alarm on that, we're going to trigger that output. So these we'll kind of worry about later. These are pretty simple. We're just going to go through those one by one, but I want to get the base code down. So let's go back over to RSLogix, and I'm going to open a project that is similar to the one I know I'm working on right now, which is a project I did for Escondido. Pro tip: if you go to Window, Arrange, Default, it'll fix those windows for you. So if you can see over here on the on this project browser over here, what I've done is, I don't know if you could see that. I'll try to zoom this in. So what I've done here is I've basically set aside. Turn the music down just a little bit. Okay, how's that? Is that better? Okay. So what I've done is I've set aside so here we have main program, and maybe some of you guys have seen pretty much the whole code written in main program, but what I like to do is I like to have my different subroutines, and my main program, it just calls those specific subroutines. and then I can basically use bits to turn on and off those subroutines, and that makes it useful for troubleshooting or for modularity. If you want to turn off a specific pump or something, you could do that. And then like each one of these would be each one of these additional ladders. So like this fan 1, this fan 2, these are the same. And ideally, I wouldn't have to edit each one of these 3. Like let's say I came in here and I wanted to add, you know, like I wanted to add another bit here for this interlock condition. Well, I have to go here to fan 1, then I have to go here to fan 2. Then I have to go here to fan 3 and make those same changes. With Studio 5000, RSLogix 5000, you have the function blocks, so you wouldn't need to make that change. But this is what we're tasked with, so this is what we're gonna do. So let me just say, all right, project. Let's just go file. Let me put this back to normal. Okay. So I'm just gonna say file. Save as, save it on the desktop. Make a folder for it. Let's call this lift. Oh shit, wrong keyboard. I got 2 keyboards here. And what am I gonna call it? I'll call it lift underscore station. Oh, did I save it in that folder? I'm gonna close it. I have OCD. I want to put it in this folder. Then I got on the folder on my desktop. I'm gonna open it back up. And now we're editing a copy of my previous program, and it's really similar. It's already got 3 pump. Actually, it's got 3 fans, but I can edit those. Window arrange default. I can edit those to be pumps really easily. So I'm just gonna do that because they're actually very similar. I'm just gonna call this pump underscore 1. I'm just gonna delete these 2 right now. No, I'm gonna leave those. Underscore 2. Rename pump underscore 3. So let's dive into what this pump program does. So if you see, so basically I have an interlock condition. Now just wherever it says fan, just imagine it say pump. I'll show you guys how to do that real easily with CSV import and export. But so imagine each where it says fan, just imagine it say pump. So I have this interlock bit. When the interlock bit is false, when the interlock bit is true, it means it's interlocked. That's why we have a normally closed contact here. Anytime it becomes true, this will no longer be bridged. And it will not only prevent the pump from starting, but it'll also stop a pump that's already been started. That's not to be confused with a permissive. A permissive will only prevent it from starting, but if the permissive becomes not valid during its running time, then it won't stop it. So then we have basically 2 methods of controlling the pump. We have a manual control mode, which basically would then allow you to start or stop it via toggle buttons on the HMI. So here we have manual start. If that bit becomes true, and we're not stopping it, then it's going to start the motor, and it's going to latch it in here until you hit the stop button. After we get those commands from the HMI, we're going to go ahead and unlatch them on the very next rung, so those commands don't get lost there. And then, so contrary to manual software manual control, you have auto control. So I just used 1 bit. So when iManual is not true, we're going to assume that it's an auto, which means we're going to look for an auto start bit. This master auto was like a big 1 bit that I put throughout the whole plant, and it's basically if you want the whole system to be an auto, you turn that bit, and if you don't want it to all be an auto, then you turn that bit off. But we'll probably end up just removing that, but I'll just leave it in there for now and just leave it on. So that's pretty much the basics of a pump motor control circuit. Here we have some fail to start, fail to stop logic, and then you know, fail to start timer, fail to stop timer. And here's all the fail conditions. So any of these conditions will become true. We're gonna latch in failed, and I'm using the latch instruction here as opposed to doing a mechanical latch. Really, the preference is on the developer, one way or the other. It's completely fine, you know, as opposed to using a coil and latching it in. I just thought using a latch bit here would be easier. Then we got our reset. It's going to unlatch all of those alarms. And then we have some runtime stuff here, some start counts, runtime. No, that's pretty much it. This is very simple. So let's export the tags, and let's just change those to, instead of fan 1, we're just going to call it pump 1. And then we'll make sure that we have our, then we'll start working on our IO map, because basically that'll be done. And then we can define the auto condition and the lead lag, and let's go from there. So we're gonna go to Tools, Database, ASCII Export. And we're just gonna want the addresses and symbol descriptions, I believe. Okay. We'll put it under user sofa desktop. Okay. Alright, let's go back to here. Now we see it here. Nope. Alright, so let's copy this. Let's go over to my desktop. And I'm going to open this with Excel. See, we didn't import it correctly, so let's do that again. File, open, lift station. No, what was this? Don't save. Alright, file, open, lift station. But under here, we're going to want to say it's delimited. And we are not tab, we're comma delimited. Alright, there we go. Next. Yep, and we're making sure that here's where we can define the format of each. So I'm just going to say it's text, general, finished. There we go. So now I should be able to just edit this file. Let's go control find, replace, fan underscore 1 underscore with pump underscore 1 underscore. Replace all. Let's do the same for fan 2. Make that pump 2. And then we're gonna go to fan 3. Guys, you would never want to do this. Like, ideally, I mean, if you have to do RSLogix code, this is the way you want to do it. You want to use the spreadsheet to do all your tags and stuff. So, but you never want to, like, you know, the best way to do it is have function blocks. So, I mean, unless it's a super small project, I think it's worth the extra money personally to let's just open this with Notepad just to take a look at it. Do I have Notepad++? I don't have Notepad++. Let's get Notepad++ real quick. Super key. My laptop actually just died the other day, so I'm like having to reinstall all my software and stuff, so bear with me. But yeah, Notepad++ is super key text editor for programming, for looking at log files. There's so much, you know, text formatting that it can do. Super key. So once we do that, I'm just gonna open up, make sure it looks good. I'm gonna copy it back over to my VM and import those addresses and descriptions. And then it's actually gonna start looking more like like the code I'm supposed to develop. This is half the battle. It's just, you know, making sure your system's set up right, make sure you're up to date with all the latest softwares. I'd say like half your job as a PLC engineer is not just, I mean, PLC engineer, that's a really bad word. I don't really know how to explain what I do. I do SCADA, PLC programming, software programming, SCADA configuration, radios, documentation. I do everything, you know, like that's what we do as an integrator. We're database engineers, we're everything like that. So here we see, yep, looks good. I guess we could have edited it right in Notepad plus too. So, all right, let's copy it back into our VM, paste, copy and replace. Let's go back in here, and now we're gonna go to Tools, Database, ASCII import. Yep. Overwrite, okay. Then we're gonna go up to our desktop. Alright, I'm canceling. Hold on. It was asking me to import everything. I just want to import addresses and descriptions. Okay, so overwrite. Okay. There we go. Now it should be happy. Could not import the RSLogix 500 documentation database files. Why? It's been a while since I've done this, so let's figure this out. Alright, let's open up the database. Let's do a CSV export. Maybe that'll be a little bit easier. Database, ASCII export. Let's go CSV. There we go. There we go. That'll do it. So let's just do that again real quick. Okay. Okay. There's the CSV. Let's just open it right in here. I forgot I have Word on my VM. Much easier. Okay, find. Oh, Jassy, what's up? Good to see you. I am doing some work right now, so I'm gonna find fan 1. I don't know if you could see this.
Viral hacking, and it's the exact same strategy that Dropbox used to grow into $1 billion.
So I'm taking, basically, I'm taking a program that was written to control 3 fans, and I'm making it to control 3 pumps. Pump 1. So I'm just kind of modifying this spreadsheet right here, doing some find and replaces. Never type anything in by hand. If you're typing in something by hand, you're doing something wrong. I guess I'm typing this in by hand, but to an extent.
Because on this training, I'm going to show you how you can easily add this into your own business, how you can add this to your own website, or even if you don't have a website yet, you can still leverage this.
All right, let's try to import this back again. Tools, database, ASCII import. Let's go CSV. Okay. Let's see if this works. All right, I'm going to get rid of this advertisement. Sorry, guys. How's the music level, Jassy, compared to my voice? Can you still hear it? Can you still hear me? So here it's saying collision, 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 collision. Okay. What is this? That didn't work as well as I thought it would. What the heck? Oh, I can't really see this right here. What the heck? Well, the addresses are right here. I don't know why they're not showing up in the... Reporting it. Alright, so open this up. Let's try this again. Why was it not? It's like it was there, but it wasn't, you know? So it's definitely in the database. Why is it not? Okay, so I gotta find test, test, test. That's what I did.
From home without working for
Test,
anybody,
test, test. Where is
Ready?
that?
Okay, let's get into it.
So here it's saying B310.
Using Shopify. This is just a simple tool that anyone can use to create a website that sells items. Then what we do is we sell these sewing machines from our website for $39. Then someone comes to the website, they buy the sewing machine for $39, and then we go to another website, buy it for $15, and then send it to them, and then keep the $24 profit. That's it. And that's the entire business model in a nutshell. Now, look, we're actually having a live class today where we're going to show exactly how to do this from absolute scratch. And to prove that this concept works, we're actually going to build this store right in front of you, and we're going to get it to $300 a day in sales. And more importantly, we're even going to take another store from $0 to $137,000 in sales within 30 days. And this live class is 100% free to attend. All you need to do is click in the upper right-hand corner if you're on mobile, or the lower left-hand corner if you're on your desktop. It will take you to a page that looks like this. You enter in your email, and that's it. Really,
there we go.
That's all there is to it. I'll just restate it again. We use a simple software that even a beginner or person.
Oh, that's the issue. I already have pump 1 and pump 2. Damn it.
We sell it for $39.
Got it. Okay. All right. I got an idea. All right. So I already had pump 1 and pump 2. That's ridiculous. Okay. So I'm gonna go back to DMSCon. I know exactly what did wrong. What I did wrong, guys. I'll share it with you guys in a second. So we had fan 1 and fan 2 and fan 3. But we also had pump 1 and pump 2. So pump 1 and pump 2 collided with other addresses. So I'm just going to go here. I'm going to do an ASCII export, CSV, DMSCon, okay, to the desktop. Okay, with me so far. So now I'm going to go back into this spreadsheet. And I'm going to rename pump 1 and pump 2 first. And then I'm going to rename fan 1, fan 2, and fan 3. So we're going to replace pump _1_ with pump. I'm gonna call this 001_ replace all. Okay, and then we'll go to pump 2. So as long as we do these first, then the names won't collide. Replace all. Okay, now we can go into. Oh, I don't want this advertisement. Sorry. Now we can go to fan 1. And we'll rename that pump _1_ replace all. Okay. We'll go to fan 2. Pump 2. Replace all. Okay, and then we're going to go to fan 3. And put pump 3. Replace all. Okay, close. We're going to save this as something new. Call this pump station import tags. We're going to go back to our lift station. Arrange default. We'll go to tools, database, ASCII import, CSV, addresses and symbols. Okay. Let's look on the desktop. This will be pump station import tags. Okay, now let's try that. Let's close it and reopen it. Save it, yes. Uploaded. New tag descriptions. See, it kind of seems like I'm wasting my time, and in a way I kind of am, because this wouldn't even be an issue. Like in Studio 5000, this would literally be one tag, a data type called pump, and I would rename that from fan 1 to pump 1, and all those tags would all just be attributes of that data type. But I'm not complaining. We're just gonna get the job done. Like I said, RSLogix 500, perfect for learning on PLC program. Terrible for actually, well, not terrible, but not necessarily the most efficient way to do something. Why is this? It's like not working. Fuck it, let's delete DB. No. Let's export the database first. And then let's delete it. Tools. Database, delete DB. Okay. Yes. Okay. Now let's import the database now.
You've got a business to grow, but that takes time. Fiverr to the rescue.
Desktop.
Freelance services for lean entrepreneurs like you.
There we go. Okay. Beautiful. Now we've got our tags. Let's go ahead and delete these pumps, because those ones, so now these are going to be pump 01. Yep, so let's delete these. Let's delete stuff that we don't need.
Smart filtering helps you find your style, price that fits your budget, and your timeline. Wow, that could not have been easier. Now, pick a service.
Let's delete pump 2.
Nice. Check out the gallery.
Let's delete the nutrient
Compare
pump.
options.
Delete. Analog alarm. Let's leave that. Water valve. Let's...
When you're ready,
I don't know if we have any valve. Let's just leave one valve just in case.
they'll do their magic. Ta-da! Wow, that looks awesome.
HOA.
Love it?
This is a little thing that I did to make to determine based on the HOA based on an auto input what the HOA status was: 0, off, 1, auto, 2, hand. So that just made the display a little bit easier on the HMI. Interlocks. So let's just remove the stuff that we don't need out of this actually. So we're gonna have pump 3. We don't need this pump 0, 0. Delete this stuff. Now we just got the 3 pumps. Okay, analog alarms. So these are cool. So like tank level was the first analog input for a particular, code, and I have everything loaded into F80, and then the next one I think is like F810. So then to continue that pattern, F820 would be the third one, etc. So, and then it's just copy, paste, plug, and chug to get all the analog inputs down. So then we have a water valve. Oh, it looks like I only implemented high and low alarms. I'm not sure if they require high and low, but we'll see. That's not too hard to add. So then we got interlocks. These are all the interlocks. Let's just delete anything that's not pump 1, 2, or 3. Water valve interlocks. Just delete all this. Okay. Pump 1, 2, and 3. And we might change some of these bits. We might rename some of these tags. We'll get into that when we're doing the IO mapping, which we're gonna pretty much get into here pretty soon. We're only 30 minutes in, but I feel like we're already actually kind of getting a lot of stuff done. So, fan auto. Here's some logic. I'll leave this here, but I'll actually just rename it to pump auto. So what I'm going to do there is it's just going to be all the automatic control for pump 1, 2, and 3. I might have another section for pump auto rotate. So I'm going to delete this secondary pump auto because I don't need that anymore. Then I have MOV 1, 2, and 3. I'm just going to delete 2 and 3. I don't know if I... Alright, so now we got more simple programs. So let's rename these. Call this pump underscore 1. Rename, let's call this pump underscore 2. And we'll call this pump underscore 3. Okay, so let's go back to our mapping routine and delete anything that we don't need. Interlocks, fan auto,
Listen to me.
fan auto,
We don't want to kill any of you, but trust me,
pump auto.
we will. Wake them up a little.
That's interesting.
It's pretty much done. We're more ghosts than people.
MOV 1, 2, and 3. Okay, so now we've gotten that cleared up. So let's just start mapping our inputs.
You have got
So what I've done here, this is a pretty common practice in.
crush us.
Adjust this a little bit. This is a pretty common practice in PLC code development, is to have like an input routine where you map all your inputs, map all your outputs. In certain controllers like the RSLogix, it's the execution of the code is done like this: read all the inputs, put them into holding registers, run the code, read all the outputs, put those outputs physically into holding registers to go out. So everything's done like continuously and sequentially, synchronously, one would say. Things like the RSLogix, they actually update their I/O asynchronously, and RSLogix. So you could be in the middle of a routine. You could have one normally open contact with an input and an output. Then you could have a normally closed contact with that same input and another output. And you would normally expect neither of those rungs to be true at the same time in the same scan. But with RSLogix and RSLogix, it's not necessarily guaranteed, because the I/O is always being updated in the background. So it could scan one rung, the input could be true, and that output will go on. And then the very next run, that input turns false, and that very next rung, it's false. So then that output right below it goes on as well. So some people will do things like they'll map the I/O into stages. So then that way they get around that, right? They read all the I/O, they map it into a, they buffer it, and then they run their code to prevent issues like that. It could be good, it could be bad. It could be useful if you're in a really high-speed process where this, like, you're looking at milliseconds and your scan could happen, and you want to know the latest I/O, like for each line of code that you're running, not necessarily the whole scan as one. So it's just a bit of a technique that I use. So anyways, so what I need to do here is just really these are the physical input addresses, and these are the mapped input addresses into my structure. So the way that I did it was B3 data block. I have bit integer number 10, and then bit 0, bit 1, bit 2, bit 3. Everything with a B310 is for pump 1, and that same pattern continues. B320 for pump 2, and B330 for everything pump 3. So pump 3 run is B330 0, pump 1 run is B310 0. What that allows me to do is I don't know, it just makes a lot more sense. It's more modular, so you could literally just replace this one letter right here with the pump number. So if you had like a dynamic, like if you had a data type structure, like for example an ignition, a UDT, you could use like parameters to parameterize your tags, and you could have 100 pumps and no big deal. You know, again, this is all much more easier on the ControlLogix with logical tag names and CompactLogix with logical tag names. So instead of addressing B323, you just say pump2.overload, you know? So it's much more logical. So again, try to do that if you can, but if not, this is what we're left with. So so might as well make the best of it that we can, right? By making it as nice and neat as possible. So really, let's see. Here's what I'm gonna do. So I got my code up here. Oh my gosh, you guys. Sorry, I've been not paying attention to the chat. Hold on. Remove. John Wick, how's it going? Let me just put this back here. So, okay, now you guys can see the chat. Let me catch up. Coding C++, Visual Basic. Nice. Good to hear. Thank you for tuning in, Jassy. Enjoy your nap. Yada. Thank you for joining in. Good to see you as well. All right, let's get back to it. Okay, so yeah, so this is one screen that I have like right in front of me, and then this screen right here I have right below me. So between that, I'm basically gonna just come in here and I'm going to update this IO based on what I see here. You know, actually I could just do this in the spreadsheet. Let's do that in the spreadsheet. If you guys haven't noticed, I like doing things in spreadsheets. So these are all of our B3 blocks. Let's just zoom in on this for you. So we are going to scroll down here to the actual physical inputs and outputs, which is down the IO. Okay, so here we go. Let's see if I can actually just copy this and I'll just paste it here. Oh, no, 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 go down, go down. You guys see that? Okay. So I'm gonna go here. I00, that's basically gonna be this guy right here. See that? I00. So pump 1 is in remote. So I'm gonna call this pump 1 auto DI. Hopefully that doesn't mess up our stuff, but anyways, call it 01. That'll help us. So then that way it won't collide. Okay, so then pump number 2, this is pump running. And I append it with DI so I know it's a digital input. Okay, so then we got pump 1 fail, so I'll just call this pump 01 fail DI. Then we have high temp, pump 01 high temp DI. Then we have high moisture, pump 01 high moisture DI. Then we got pump 2, so then let's just go here, C, V, fine, place, 01, 02, replace all, okay, Control V, fine, replace, 03, place all, okay, and that should be good. So just to verify that we ending on pump 3 high moisture, which should be input 14, input 14 right here. You guys see how I did that? They're just continuous, so I know that if I have pump 3 moisture right here, they all have the same number of tags and they're sequential. Then I can just copy and paste it. So these are my inputs right here. Now when I import these within my program, I'll be able to see exactly what those inputs are when looking at them. But basically you never want to really use this physical input address throughout your program. You just want to use that in the mapping routine, map it into your data structure, so then your HMI tagging becomes much more simple and not like arbitrary. Like 1, 2, 3, 4, 5, 6, 7, 8. Like there's no thought put into that, right? Okay, so now we gotta go past 14. Now we have CR1A. Now what the heck? Okay, in 15. Okay, so it's that's okay. Got it. Okay, that's just the labeling, but this is the actual input. So it's still a input, but it's coming. The input's coming from the CR1, the 1A to 1B. So when that control relay is energized, that's going to give us an input. But anyways, it's float switch. Call it float switch WWF LSH. I'll call it FS WWF LSH underscore DI. Okay. Oh. FS lead. Oh, no. It's not. That's the next one. FS float switch WWF LSH. FS lag underscore WWF. You know, I'm just gonna use this WWF. No, I like FS, so they're all gonna be float switch. FS lag. FS lag. You know what? I'm just gonna do WWF. World Wildlife Foundation. WWF LS lag WWF LS lead underscore DI underscore DI. Okay. Now we got our WWF LSL. WWF level switch low DI. And then WWF LSLL underscore DI. Okay, cool. That's it for the 19 inputs. Let's go over here to our, and this is all the holy shit. This is all our onboard chassis IO for this micro. Let's see, RSLogix 1100. Okay, oh no, 1400. Okay. Yeah, we'll figure it out. I think this is the onboard IO, if it's the RSLogix 1400. But is it a RSLogix 1400 or is it a RSLogix 1100? It's a 1400. Guys, look at this. See this? PLC number 4. Number 4, PLC 1766 L32BXB. What is that? This enclosure. Let's see if we can find the datasheet of the PLC. I can't tell what it is now. I'm pretty sure it's a RSLogix 1100. I remember seeing the panel yesterday. It's in the middle of construction right now. Pretty sure it's an 1100, which means it still has some onboard IO, but I don't think it has as much as the 1400. Oh, it is a 14. It's 1400. Right, look right there. I actually did the submittal. Yeah, we submitted a 1766 L32BXB, which is a RSLogix 1400 PLC. Just the drawings just happen to show an 1100. what to me what looks like an 1100. I know the 1400 looks similar and uses the same I/O, but I thought it was a little bit wider. But anyways, we're just gonna go with what's according to this I/O drawing, which is RSLogix 1400 with 20 in and 12 out. So here's our 12 outputs. So let's just do those now. So I'm gonna move this back over. Okay. I'm just gonna remove this right now. Okay. You guys are just gonna have to trust me. So output number 1. It's gonna be O. The address is gonna be O, I believe. 000. Okay. Call this pump 01. Pump 01. Start DO. Start DO. Start DO. Oh, sorry. Alright. So then after pump 3, we have a high hydrocarbon level. High hydrocarbon DO. I have high oil DO. High basin DO. LVL for level DO. There's a maximum number of characters, and it's like shorter than you would think, but I think we might be okay there. I think it's like 30 characters or something. High oil, high basin level. PLC fault alarm open on fault. Alright. Open on fault. So really this is PLC. Okay. Fault. NO. DO. Normally open. Or no, NC. Normally closed. And we have UPS fail. Not sure if that's open on fault, but we'll see. You can always change that like real easily on site. Alarm beacon DO. Sometimes you gotta just keep moving on. Like maybe if you don't know exactly what it is, normally open, normally closed, just move on. Figure that out later. You gotta like keep making progress, you know? You could just get tied up in the weeds and not get anything done. Alarm beacon DO. Okay, then we got lit underscore 1 underscore fail underscore DO. Spare underscore DO 1. Alright, let's call this spare DO 10. And we'll go spare underscore DO 11. Okay. Cool. Alright. So that about does it for... That's for these IOs right here. These are the outputs. So let's zoom back out. So we got all of our inputs, not necessarily mapped, but we got them tagged in our Excel spreadsheet, which is the important part because it's going to help us when we're mapping it and doing startup and stuff. We got all of our outputs on the first onboard IO mapped. So let's scroll down to our first card. We got a RSLogix IQ16. This is going to be a couple IOs here. So let's see, we're going to get these right here. We're on the first card here. Input slot 1, so that's going to change our IO addressing. Then we have high level, low level, oil and water sensor transmitter fault, gas detector transmitter fault, high discharge flow shutdown, UPS on battery, UPS low battery, UPS trouble, spare. So let's go back into our spreadsheet. Delete those. Okay, so this is what this IO would line up to be right here. So actually I1 for the first card, 0 is the onboard card, 1 is the first card, I for input, 0 for the first one. So we got first one is going to be what you see right here. Let me zoom in for that. High level LSH1. LSH DI. I wonder if it should be WWF. Yeah, WWF, wet water fountain or something. Can be consistent with the other ones. WWF LSH DI. Is that not? Oh, that I already have that. That's just LSH DI. I don't know what the difference is between that. LSL DI. Oh, I need to get battery plugged in here pretty soon. Alright, so it's saying LSL1 and LSL1, LSH1, LSL1. Then we have AIT underscore 1 underscore sensor transmitter fault. We'll call it fault DI. Then we have a gas transmitter AIT2 fault DI. AIT2 fault DI. And then somewhere in here, I think it's the description. Yeah, so I'll put this here. Oh, this will be oil and water sensor. This will be gas detector transmitter. Alright, what else do we got here? High discharge flow shutdown, FIT1. FIT underscore 1 underscore high shutdown DI. UPS on battery, UPS on battery DI, UPS on UPS low battery underscore DI. What kills me is when we did this project with all of these inputs and outputs, it should have been on a spreadsheet to begin with, so then I could just copy the spreadsheet into this and import it into the program, and then that same spreadsheet can then be used by our designer to design this. As a matter of fact, you know, most AutoCAD CAD programs should allow you to import a spreadsheet and automatically do your IO drawings with labels and correct IO addresses based on a hardware catalog of what PLC card you're using. So it really bugs me that that's not the way things are done at my current place, but that's what I'm trying to get to, is because I'm technically wasting time right now by doing this. I just want to make that fully clear. Like this is not the ideal way to do it, but this project was just kind of thrown in my lap. I just got to get it done, so I guess that's just the way we operate there. Don't worry about improving something. Let's just get it done. Oh, my computer's dying. All right, let me go get a charger here. No offense to anyone. I'm just saying what I see, you know? I mean, it's my opinion, you know? I think there's a room for improvement. You know what I'm saying? Like a database should be the central point of the project. all information should propagate out from there. That's the central communication, is a spreadsheet. What are the inputs? What are the outputs? Let's assign those inputs and outputs to IO addresses. Let's create the drawings. Not like create the drawings and then, I mean, if another company designed these drawings and then they just give them to me, yeah, then this is what I would have to do, right? I mean, it's a pretty good way of communicating information, but I think if you're developing this whole PLC panel in-house and doing the drawings in-house like we're doing, like there's probably a better way to do that. So it's actually really cool being able to talk about this to you guys, because it's helping me create ideas as far as how we can improve this process. But we're about 50 minutes in. I'm gonna take a quick 5-minute break. I'm gonna go get my laptop charger and then we'll hit it again. I'm gonna stay live though. So yeah, we had someone from Egypt in here earlier. That's awesome. Yeah, so I'll be right back. Let me just add a... All right. All right, be right back, guys. Didn't go that quick. I'm just getting my coffee cup. Let me get some more coffee.
Everything you said we already knew, more or less.
Well, here's something that you didn't know. 2 of those special atomic bombs haven't gone off.
What's up, guys? What's up, guys? Zach Scriven. What's up, guys? Zach Scriven here. What is up, guys? I'm back. Drop the DBs on this. Okay, so we are back. See this? Testing 1 2. Alright, there we go. We all back. We're plugged in, we got coffee, we got water. There we go. So basically, I'm editing the spreadsheet of all the inputs and outputs right now. It's gonna be our labels and descriptions. So let's finish this out and then we'll import it and actually do that mapping. So UPS trouble. It's a spare. Okay. There we go. Okay. Now we got the inputs for this card done, so let's see how many more cards we got here. Now we have an analog input. We have 2 analog inputs. I'll show you guys here. Here's our analog input. It's FIT1 coming into slot 2 input. So this would be I2 1. Is I2 0? I2 2? That's not right. That should be I2 1. That's a mistake. Yeah, I2 3, I2 3. Yep. Let me see if I can mark this up. Anyways, that's what happens when you do your drawings manually. Anyways, okay, so I'm going to say that's I2.1, I2.3, I2.4 over here we should have i3.0, i3.1, i3.2, and i3.3. Those are all spare. So let's flip over to our spreadsheet. Let's do these. Alright, so this is i2.0 ph raw. That's weird. Looks like somehow there was something. Okay. So we got i2.1, i2.2, i2.3. Boom, we'll go replace :2 with :3. Okay. So this is going to be fit_1_AI raw. This will be i2.1 will be lit_1_AI_raw. And then we'll do ait_1_AI_raw. Then we got ait_2_AI_raw. Then we got, these are just going to be spare. AI 3-0_spare. AI spare. See if we can catch that. Nope, didn't work. Okay. So let's head back over to our spreadsheet. So we got all these in. Got FIT1, LIT1, AIT1, and AIT2 addressed. Then we got some spares. Then it looks like we have one more card, which is an analog output, slot number 6. So that's going to be, you know, let me fix the hardware catalog real quick. Let's save that for now, and let's go to our hardware catalog. Let's configure the hardware. Okay. IO configuration. So do we have what matches here? Go up to my drawings. I don't know if that's slot 6, but okay. So we got DI1, AI1, AI2, and AO1. So DI1, AI1. Six and 6, 5, 6, and 7. So I'm gonna go over here. 5, 6, and 7 is some catalog numbers. IQ16, IQ16. Oh, IF4 and OF4. So I don't know if you guys could see that, but we're going to go number 2, and we're going to go IF4, IF4, and OF4. Okay, so that looks good there. That matches what we got. Okay. Okay. Okay, so now what I'm thinking is the analogs, the analog alarming was very pared down on this last program. Like it didn't have high, 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 low, low, low. And I think they want that. God, it's gonna be such a pain in the ass. Okay, so we got tank level, which is not necessarily gonna be tank level. It's gonna be whatever the first one is on our spreadsheet. Pump 1. Slot number 6. Okay, so I'm guessing we're gonna want high, 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 low, low, low alarms on all of these. So really, I just need a standard alarming thing, and then copy that 4 times over. So we need high, 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 low, low, low set points. We need all of that, right? So let's see what we got here. We have tank level F80. F81 is the low set point. F82 is the high set point. Yeah, no, we can't do that. We're gonna go to our database. What do we want? F8, we want low, low, then we want low, then we want high, then we want high, high. You know, I'm just gonna go up to 100. F8 100. Because I got some other stuff that's shoved in here that's not really where it should be. So I'm gonna go up to 100. So 100 will be input 0. 110 will be input 1. So we'll do something like this. AI. Thank you to Wonderwear California for sponsoring this episode. So this is what we're gonna do. This is gonna be the model. So this will be AI 0 underscore EU. This will be AI underscore 0 underscore LLSP. AI underscore 0 underscore LSP. Add new record. F8 103. AI underscore 0 underscore LH. Or no, HSP. Yeah, see, L is level low. We'll just want. Oh yeah, LLSP, LSP, HSP, HHSP, high set point. Insert record F8 underscore 104. AI underscore 0 underscore HHSP. Okay, boom. That works. And then somewhere else we're going to have the alarms, which is going to be in a Boolean address. B3. Where did I have that? Let's make a new block. Vetting investors and opportunities has never been simpler. Sourcing deals has never been easier. Make a new data file. So we have F8. Let's add new 9. So we'll call it 10. B. Call this analog alarms. Analog Allah. Elements 200. Okay. So B31000. Call it B3. B31000. B10 100. What did I put it into? B304? Yeah, see, I kind of didn't have very good structuring before. This is why I hate the blocks. Like a million different ways to do it. I like the names. Okay, so let's just go to B310, B1000, B10. LLA. Level low alarm. I'll just make that. Bam. Okay, then this will be LA. LALL. Then this one's going to be okay, I'll call LL alarm. There we go. And this will be L alarm. This will be high alarm. And then this will be high alarm. Okay, that works for me. Okay, so let's make another timer block too. New data file. We'll call it 10. We'll make it a timer. Analog TMR. AI TMR. Oh, okay, 10 already exists. Let's go 11. So we need to change the number of elements. So timers are weird. So let's make it 100 elements. So we're gonna do 0, 1, 2, and 3, and 4 for. So this one is gonna be T11.0. This will be AI _0 _ TMR. LL LLA _DLY. And then this next one's going to be pretty much the same thing. AI _0 _ LLA DLY. So LA low alarm DLY. Then we got AI _0 _ HA high alarm DLY. Then we got this one, which will be AI _0 _ HHA _ DLY. Okay. Then we're gonna jump down to 10. So this will be AI _1 _ LLA _ DLY. And the pattern continues. I just want to have one, or I want to have 2 done. So then that way I can see the pattern. If I export it, merge it with my other comments, re-import it. Instead of using AI, it'll actually be something logical. AI _1 _
This is for the dreamers.
HA _ DLY.
For the innovators.
AI _1 _ HHA _ DLY. Okay, boom. So there we go. And this can scale all the way up to like 10 analogs because we got up to 100. So we got 0, we got 1. We're gonna have 2, 3, and 4. That'll be cool. So we got these timer bits. So this is actually going to be T 11_0. And then the floats, what do we have? So F8101, right? Which is the LLSP. Okay. So if the AI0EU is less than the LLSP, we're going to start LLA, a level alarm delay. And then if that delay finishes, we're going to do B10 001. Okay. If we get a reset, we're gonna unlatch it. Okay. So this is the workings of a low alarm right here. We got a condition exists, start the timer. Let's see. Condition exists, start the timer. Timer finishes, a level alarm. Reset, unlatch it. Perfect. So I'm going to delete these. And we're going to copy these. Paste these. So now instead of 1, it's going to be 2, I believe. That's the low alarm. Oh, no. This is the first one. Edit comment. AI0_alarm. Put that in the title. So if it's less than the low set point, start the low timer. When the low timer finishes, low alarm. Reset the low alarm. Let's do the same thing for high. High set point, but now we're going to change instruction type to GRT or GEQ. What's the LEQ? GEQ. What the heck is that? Oh, no. Oh. Okay. If it's greater than the high set point, start the high timer.
So while we're modernizing the electric grid, the Garza's modernizing.
If the high timer finishes, reset the high alarm. Or set the high alarm, then reset the high alarm. So now we just need to do these 3 lines, one more. You see why I'm saying that this is ridiculous? Okay, so this should already be done for us, you know. So this is our high set point. We're going to do a high timer. When the high timer finishes, high, reset our high. Okay, there we have it. So there's a low alarm. Edit comment. Low alarm starts here. Then we got edit comment. High alarm starts here. And we got a high alarm here. That's it. AI 0 alarms. It's getting kind of hot. Okay, so what are we doing here? We got all the analog input 0 alarms. So we need this 7 times. Now let's just do the first 4. The spares, I'm not gonna add the code for. Too lazy for that. I think I'm too lazy for that. Because then I gotta change every single thing. Alright, let's just do it. So this will be rename. We'll call this analog 0. AI 0 alarm. Analog.
Every moment you made each other smile.
AI 0
For all the moments you were filled with
alarms.
wonder.
Let's make a new.
And from that
Let's
first
rename this
moment,
actually.
you knew that she would always be your hero. This Mother's Day, thank her for all she's done, and let her know how much she inspires you every single day.
We call this 100. Okay, I'm just gonna delete this right here. Alright, we're gonna make a new one. Let's just do all 7, whatever. For shits and gigs. Let's just do all 4. Take it back. So this should be this guy. And this should be this guy. And this should be this guy. This should be this guy. I think. No, that's where we're gonna go. How did I make that? How did I anticipate these? Let's go B through 1, yeah, fuck it. Let's go right here.
This is your business. You want the best. So, what about your internet and phone? Technology's moving fast. Gotta keep up. DSL's not gonna get you there. But Spectrum Business will. Faster internet for less. And technology that puts you ahead of the curve.
I forgot the naming convention now. For the timers. Timers are weird. So this one's just going to be LL timer. Okay. So this is the... So this is going to be AI1 underscore LLSP underscore. What the heck? Why is that not working? Okay. LLA underscore DLY. Okay. It doesn't like that for some reason. What is our LLA DLA? Okay. I'm trying to copy this. It doesn't like that. Oh. Okay, so it's not 21. It's still 10. Cancel. There we go. Timer. So according to our convention, it's not going to go to 21. It's still going to be T11, but it's going to be 10. There we go. Made a mistake. Shit happens. There we go. Okay. I think that's pretty much it. Let me check our floating table file. So we got 0, high set point, high set point. Yeah, so 0 is going to be our EU, and then LLSP, LSP, HSP, HSSP. and then to F110. F110 should already have those. F120 should be the same thing. All right, I'm just gonna copy this one right here. So 120 will know we've already got it started. Ah. This will be I2. Okay. Okay, let's fix our timers here. Now you can have like, this code can be just saved as text, and you can come up with some elaborate way to, you know, automatically generate these text lines and stuff like that. But I mean, seriously, modularity is where it's at, you guys. That's analog 1 EU, analog 1 EU, LSP, LLSP, LSP, HSP, HHH. Alright, whatever. Why is that one not there? Oh. I gotta make sure to do this right here too. Make sure to put this one here. Okay. You know, I could just have like, I don't know. No, that's good. Why is that one not a thing though? $112, $113, $114. So I think maybe I just didn't finish those in. FA 1, 10. I just haven't competed them in yet. Alright, I'm gonna finish those in. Then we're gonna get this back into the spreadsheet, and we'll start doing some spreadsheet stuff. I just kind of have to have like the model down, kind of get an idea of what I'm gonna do, and then I'm just gonna do it. Okay. So let's just export these tags. I'm calling it Y with AI to our desktop. Okay. Okay. So I really want to import in, let's import in those tags that we already, because we did all that work, right? So let's go back to our spreadsheet. All right, you guys can still hear me. Oh, we ran out of music. Let's go back to our spreadsheet here. Save this. Because it has our raw analog input and output mapping. And right here, when we say, yeah, cancel import. Okay, so when we go to tools, database, ASCII import, CSV, we're gonna import addresses and symbols, but we're not gonna, see this discard imported ASCII records? That means if we wanted to discard everything, we'll do that towards the end once we wanna get rid of a bunch of, stuff that's not actually there. But right now, it's gonna overwrite so we don't delete all this new stuff that we did. And we're gonna grab that from the desktop. This is our import tags. Hopefully that worked. Go to our input. And we have pump 0. Yeah, that looks good. Our inputs are good. Let's map our DI actually. Those two are swapped, so I just swapped those real quick. Always true. Why is it high temp? Now I'm gonna delete that. Fail. Okay, there we go. High moisture. So we don't have high moisture. So let's call that B310.5. Nope. 10 is the next unused one. We'll call this pump _1 high moist. Okay. So there's our mapping for the first pump from the raw inputs and outputs into our data structure that's formatted. The only thing we had to add to our structure from existing was this high moisture tag. So let's just continue on down here. Pump 2 auto, cool. Pump 2 run. I think that's 0. Damn it, my keyboard's not working. Why does it do that?
This Mother's Day, 1-800-Flowers.com is something that will help you say exactly how you feel.
There we go. Pump 2 run, pump 2 auto, pump 2 run, pump 2 fail. Let's overload, pump 2 high temp. I believe that's 2. Then high moisture is going to be
from day one. We bring moms 100% guaranteed smiles.
This will be pump B320/10. So then we got pump 3 auto, pump 3 run, pump 3 fail. I think that's this is not 30 anymore. Just pro tip right there. Just a little drag and drop action. 2, 3. Overload. OL stands for overload. So then high temp will go back to 2. Pump 3 high temp. Let's save. How about that, you guys? Let's save this work that we're doing. High moist, high temp. This is going to be B33010. This will be a new tag. Pump 3 _ high moist. High most. So now we got this LSH. I don't know what the hell I'm going to do with these tags. B3 _ 0/7. Now I'm gonna go B3 _ B3 0/10. Okay, so there we go. We got those mapped like that. Get this one mapped over here. 13. Call this WWF _ LSL. 14. WWF underscore LSLL.
Virtually every successful business model, promising the sun.
LS1DI. LSL underscore 1. That's weird. Oh, LSH. And this will be LSL. Oil in water sensor. AIT underscore 1 underscore fault. AIT underscore 2 underscore fault. Got a reset button. It's a HMI reset button. It unlatches some shit. FIT high flow shutdown. Oh, see, this is a L latch. We don't want to do that. We want to go OTE. Right click, change instruction type. OTE, output energize. Delete this crap. High shutdown. So this will be the, I'm just going to go sequential here. FIT underscore 1 underscore high underscore shutdown. UPS on battery DI. UPS on battery. And we're gonna go UPS low battery. You guys guessed it. UPS underscore low underscore battery.
I'm here to prove the purple mattress blows memory foam out of the bedroom. Only purple passes the door.
Pull up the chat again. We've been streaming almost 2 hours. Hello world. UPS trouble DI. Spare DIs, I don't care about those. Do I care about those? Yeah, I do. Okay, so I got all the DIs mapped. Everything's labeled. Let's do the DOs. Pump 1, pump 2, pump 3, start. Already mapped. 0, 1 start. See, I don't know what that is. Hydrocarbon. Don't know what this is meant to be here, so I'm just gonna put that right there. High basin level. See, I don't know what's gonna go there yet, so I'm just gonna make it so they're gonna always be, I don't know. We'll map that later. PLC fault NC DO. UPS fail. DO. I feel like I just had that one. We'll call it UPS underscore trouble. I don't know. Spray valve 1 open. Alarm beacon DO. I feel like that's from the other project. Let me pull up my drawings. What was that output? Analog output is all spare.
This is Will Robinson of the 24th Colonist Group. I'm the first human to discover evidence of an alien
The outputs are on
intelligence.
here. Alarm beacon. Oh no, okay, so that's good. Now that's for this project. Alarm beacon DO. Okay, so I don't know what's going to do that, but some series of conditions will do that. Alarm beacon DO. Then we got LIT fail DO. Out of range. Damn it. So we're going to need to do some sort of out of range. Oh man, I really kind of just want to do it right here. Let's do that. Input output compare. So we're going to go GRT or GEQ, or we're going to put in a parallel branch, or LEQ, and we're going to get that raw source for the LIT. I think it's AI 0 underscore, what is it, raw? Map AI. So I40, no, it's going to be I20? LIT. Show you guys what I'm doing. Going to the map AI section. There's basically a lot of, there's so much crap, you guys. Okay, so this is an analog input scaling routine. We're on IT20, IT21. LIT. So LIT is going to go, the raw value is going to be pretty much mapped in here. So we just got to grab this, map DO. So if that is greater than the raw min and low, the min and max values, that's what we'll do. Which is going to be this N711 and N7112. It's actually going to be the other way around. So if it's greater, so if the AI level raw input is greater than the raw maximum, and if it's less than the raw minimum, then it's a fail DO. Out of range. And those two are spare and spare, so I'm just gonna delete. I'm just gonna put a normally closed contact, and I'll put always true, I think. Okay. System common alarm. Yeah, we don't need this. Okay, those are our map D outputs. Map digital outputs. Okay. All right. Let's. Where are we at? Okay, so I want to get. Should I import it? Let's re-export this, and then let's delete all the stuff that we don't need, like all that other crap. Then we'll come back in. We'll have analog channel 2 and 3, and we'll add those alarms. We'll add those. We'll add what we need, and we'll subtract what we don't. We'll go back into the spreadsheet mode. So we're gonna get rid of pump 0001 and 0002. This time when we import, we're gonna say delete existing end pump. We don't need the nutrient pump. We don't need the water tank. We don't need the water valve. We don't need the spray valve. We don't need fan auto. We don't need pump auto JSR. We don't really need all those. Alright, let's just do that. Let's do that. Yeah, those are actually okay. Spray valve. Just deleting what I don't need. So here's our, okay, here's what we're gonna need to insert some. Insert. Y. Okay. Y. Control Y. So we really just want to duplicate this. Except now this is gonna be 2, 2, 2, 2, 3, 3, 3, 3. Find, replace. Underscore 1 underscore with underscore 3 underscore. Replace all. Okay, and then we're gonna do. Oop. Replace that with 2. Replace all. Okay, so there's our alarms. Let's delete this now. We got tank level alarm set point. Tank level. Nah, see, we're gonna delete these. These are our run times 1, 2, and 3. Pump 0. Tank flow. Tank flow. Pump 1. Tank level on set point. Tank level offset. Tank flow alarm high set point. No, we're gonna delete all these. These are not gonna be used. Now we got these. Okay, so perfect. This is what we need. Let's delete these. Let's do the same thing with this. With this. All right, no, let's not do that. Insert Y. Okay, now let's just zoom back out. Let's make sure we get these coming down. Don't know what these are exactly, but some column or something. Some column or other. Those are good. Those are good. Those are good, I think. Yes. Yes, these are good. These are good. Okay, now we're getting to the raw inputs and outputs. I2.1.0. Yep, let's delete all this. Okay. tank flow underscore with AI1. Find replace underscore 1 underscore with underscore 2 underscore replace all. Okay, same thing here except with 3 replace all. Okay, so now we're just gonna go here. I'm just gonna do this by hand because I'm lazy. I think if I spent like a week or two with some really smart other engineers and we all put our heads together, we would come up with the most beautiful way to structure data for any type of pump, any type of valve inside of RSLogix, using their B's and T's and N's and F's, and we'd figure out a really beautiful way to modularize it and be able to account for any scenario. But ain't nobody got time for that. Unless someone already has it, then they should publish it. It should be open source, is what it should be. Or we should just not use RSLogix, RSLogix 500. We should use Studio 5000, because this is the 21st century. It's 2018, you guys. So, now that we got that done, just delete these 2 rows. Scroll down, these are our good outputs. These are not good outputs. End pump run timer, spray valve 1 timer, spray total. Okay, now we're down for the timers. Okay, so we got AI 0. We got AI 1. And delete that. Thank you guys for joining, by the way. I see you guys. I'm trying to push the boundaries on the industry, you guys. Like, everything should be open source, you know? This is not proprietary information. Like, I'm grateful to be able to do this right now because I have a job that pays me to do this, but it really bothers me that I have to do this and that this isn't, like, it's just, it should already be done, you know? It should be, you know what I'm saying? Like, it should just be much more standardized, you know? And I think by putting this out here, like by exposing, you know, what it is that I'm doing, we can figure out ways to make it better. We can, you know, stop reinventing the wheel. Like, there's so much that can be done, but some people just think ass backwards, you guys. Like, some people might think this is crazy, but I think it's crazy not to do this, you know? I'm trying to help the world, you know? Like, people want to learn how to PLC program. You know how grateful I would have been to see you know, watch a couple-hour video of someone doing a program start to scratch. Maybe I'm confusing you more than I'm helping you, but I don't know, maybe I'm helping some people, you know? If you have nothing to compare against, then it should be helpful, right? Pump 3, pump 1 run timer. So we got our delays. I think we're good. Alright, let's just get this back in there and see if we didn't screw everything up. ASCII import CSV. Let's navigate to that. Okay, here's what I needed to do though. Tools, database, ASCII import, discard imported ASCII records. Discard imported. Oh, oh no. That's actually what I want to do. I want to tools. Let me just save. And just in case I want to cancel that database. Delete DB. No. Do this one more time. Let's just import. So we're going to import what we just made, right? So that looks good. Okay. Well, save as. I'm going to rev it. We'll go R1. Okay, tools, database. Let's delete the DB. No, I got tools, database, ASCII export, everything. Except for the EAS. Okay. See users. There's a reason why I'm doing this, you guys. Let's make a new folder. Now let's import that back in. Okay, so now that we got that going, we should be able to yes, this is good. Let's delete this water valve. Alright, so that's pretty much it for the base program, you guys. I mean, we got pump 1, we got pump 2, we got pump 3, we got our main map routines. It's actually MOV1, no. So we're gonna do GSR U100, GSR U101, JSR U102, JSR U103. That's gonna be our 4 analogs. So I'm just gonna go here, copy all this stuff, new 102, call this AI-2-ALM. Bam. So So now I gotta just switch everything to, I think it's this. Okay. Do all these first, and then I'll go back and hit the timers. See how important it is to make it like modular? I mean, I guess you could like look it up by name and stuff, but like, see, if I try to just go in here and type in AI3, what it tries to do is actually rename that to AI3. It doesn't actually, so I'd have to like go in here. Like for example, let's say, all right. I'd have to go in there, enter that, and then go AI2 underscore H underscore AL alarm. So I don't know, I mean, I guess that could work. It's another way to do it, right? It's actually not bad. It's not bad, actually. Alright, so I got all these 2020, 2020, 2020, 2020. Okay, so let's do the timers. Then we're gonna go right here. So there's low, done. Let's go to low alarm. Just change this right here to 2. Almost done. Okay, I think that should be it. So now let's save that. Okay, now let's do it one more time. New. This is going to be 103. Okay. Oh no, delete that. Not name 103. I want it to be ladder 103. Come on, you should know that, RSLogix. So let's go here. I'm gonna copy this secondary one. So we're just gonna do this one first. And do this block. So annoying, you guys. If there's a better way to do this, let me know, you guys. If you guys mastered the, besides what I'm saying, use Studio 5000 or such. If there's a better way, I am all ears. Just looking for those 2s, changing them to 3s. I'm getting pretty tired, you guys. I had so much coffee, I'm about ready to crash. Almost missed one there. See, I'm about to make mistakes. Now you guys may be wondering, it's like, oh, well, that's great, Zach. It says AI3. But what if I don't want it AI3? Ah. Well, That's why you save this program as a generic program. Okay. Then you export, find replace AI1 with FIT 101 or whatever, AI2 with whatever. Then you got pretty much modular code. Pretty much. Emphasis on the pretty much part because it's so much easier. Studio 5000. Alright guys, damn. It's almost 4 o'clock. Alright guys, I'm gonna end it here. This is pretty good. So I'm just gonna go tools, export, database, ASCII export, CSV, station R1. We're gonna put that to the desktop. I'm gonna email this to my boss. Show him the tags. That way he can start working on the HMI. I'll let him know it's pretty much done. There's basically just a few little mappings and automation portions. There's a communication piece. There's another PLC that they don't want these pumps to run when those other pumps on another PLC are running. So we got to do some messaging for that. That's going to be kind of hard to do right now without much information from the other PLC. So yeah, so that's pretty much it. I'm impressed that I was able to do that much in 2 hours. When you focus on something, you could really get it done really fast. The key is focusing. If you guys aren't aware, like I have ADD, ADHD, Asperger's, Savant syndrome / slightly autistic. You know, like why else would I be doing live streaming my work? Most people would probably be afraid they're gonna get fired, but I am not afraid. Not afraid to get fired. I'm afraid to let my life go to waste and not do amazing things. That's what I'm afraid of. Like, why shouldn't let fear drive your choices, you know? You should do what it is that your heart desires, what it is God created you to do. So, if that's PLC programming on RSLogix 500, then, you know, this 2-hour video will show you how to do some things, how I do some things, what I did in 2 hours, you know? Could I code like that for 8 hours straight? Maybe. Maybe if I didn't have so much coffee. I need some lunch. I had like a bowl of cereal for lunch, but I didn't have breakfast, so been really busy this morning doing a lot of things, getting everything prepared, and so it's pretty fun though. Oh, I did have a technical demo with Mike Lapitan this morning. So that was pretty cool. We did Wonderware Online Insight. Set that up. That was pretty awesome. So I'm doing some cool things. And then, you know, other email and various tasks and timesheets and, you know, all that paper pushing you got to do. So really, this is like just the tip of the iceberg when it comes to work, I feel like. So anyways, thank you guys so much for joining in. That's it for today. See you guys later. Peace.